What if the most profound scientific hypothesis of our age is not a product of modern mathematics, advanced computing, or futuristic speculation, but an idea that has been whispering through human civilization for thousands of years? What if the so-called simulation hypothesis, the notion that our universe is an elaborate construct, has been here all along, disguised in the myths, philosophies, and sacred stories of our ancestors? We begin not in Silicon Valley, nor in the realm of quantum physics, but in the caves of ancient Greece. Over 2 millennia ago, the philosopher Plato offered a parable that would echo into eternity, the allegory of the cave. Imagine, he said, human beings chained from birth in the depths of a cavern, able only to face one wall. Behind them burns a fire, and between the fire and their bodies pass objects whose shadows dance on the wall. To the prisoners, those shadows are reality. They know nothing else. But what happens if one prisoner escapes, climbing out into the blinding sunlight of the true world? Would he even recognize reality when it was placed before him? This parable, at its heart, is not merely about perception. It is a radical suggestion that the reality we inhabit might be an illusion, an approximation of something more profound, more authentic, more unreachable. And in that suggestion lies the seed of what we today call the simulation hypothesis. But Greece was not alone in offering such visions. Across oceans and centuries, in the rich philosophy of India, another voice was whispering the same haunting suspicion. The sages of the Upanishads spoke of Maya, the veil of illusion, a cosmic dream woven so tightly around consciousness that mortals mistake it for truth. To live in Maya is to live in a grand deception. Only through awakening, through piercing the veil, can one see beyond the shimmering mirage and encounter the ultimate reality. Does this not sound, in essence, like the narrative of a simulated world where what we take as solid is but projection, a carefully woven code of appearances? And if we journey further into the cosmologies of Native American and Australian Aboriginal traditions, we discover dream realities that blur the line between waking and imagined worlds. For the Lakota, reality was not fixed, but alive with layers of spirit and shadow. For Aboriginal cultures, the dreamtime was both the origin of existence and a continuing structure that underlies daily life. Existence itself was a story, interwoven with consciousness, echoing the sense that reality is not a singular, objective truth, but a constructed, malleable framework. What binds these diverse traditions together is not geography, language, or even theology, but a recurring suspicion that what we call reality might not be real at all. Each tradition describes the world as though it were a mask, a veil, a stage, or a dream. And in these metaphors lies a question as relevant to us today as it was thousands of years ago. Are we prisoners in Plato's cave, sleepers in Maya's dream, participants in a vast program we cannot yet comprehend? But here is where contrast deepens the mystery. For in our modern era, we often imagine ourselves to be more advanced than these ancient thinkers, armed with telescopes, particle accelerators, and supercomputers. Yet, what we find is that the very technologies meant to reveal reality's foundation, instead, confront us with puzzles that sound eerily similar to ancient metaphors. Quantum physics tells us that matter is not solid, but probability, existing in overlapping states until observed. Cosmology tells us that what we see is not the whole universe, but a tiny sliver of a vast unknown. Computer science whispers that the entire cosmos may be reducible to bits of information, patterns in code, zeros and ones strung across the void dot. So which is it? Were the ancients grasping blindly toward truths we are only now beginning to formalize, or are we projecting modern anxieties onto timeless myths? Is Maya truly a cosmic veil, or simply a poetic metaphor misunderstood across cultures? Was Plato's cave a philosophical allegory, or a literal premonition of programmed existence? The answer may never be simple. But the resonance between ancient wisdom and modern speculation cannot be ignored. It is as though humanity has always harbored an intuition, a gnawing suspicion, that reality is thinner, more fragile, more constructed than it appears. We feel it in our myths. We sense it in our dreams. And now, we attempt to prove it with equations. This convergence between old and new creates a strange and cinematic mirror. On one side, the firelight of the cave, the chants of sages, the symbols carved in stone. On the other side, the glow of quantum screens, the equations of physicists, the theories of simulation scientists. Both sides ask the same question in different tongues. Is this world real? Or are we characters in something scripted, illusions cast in a larger stage of existence? Consider how profoundly this shifts our place in the cosmos. If ancient seers were correct, then human life has always been a journey through illusion, an opportunity to awaken from deception into truth. If modern simulation theorists are correct, then we may be coded beings, avatars inside a higher dimension of computation. In both visions, one thing is clear. The reality we know is not the final reality. But here lies the tension, the contrast that animates this documentary. Ancient wisdom offers us metaphor, myth, and mystical insight. Modern science offers us mathematics, data, and experiment. And yet, they seem to be pointing toward the same precipice. The question is no longer whether humans have wondered if reality is false. The question is why this idea has haunted us for so long, across so many ages, and why it resurfaces now with such force. Perhaps it is because the closer we come to decoding reality with science, the more it slips away into paradox. Perhaps because our very consciousness, the tool with which we perceive, cannot escape the suspicion that it is perceiving a mask, a projection, a simulation dot, and so we stand, suspended between the ancients and the moderns, between myth and machine, between shadow and science. The same question echoes across centuries. What is real? But before we dive deeper into speculation, before we immerse ourselves fully in the dream of simulations and the allure of illusion, we must first pause. We must turn to the foundations of knowledge, not in myth or philosophy, but in the hard edges of physics. Because if reality is a simulation, if it is truly coded, then the code itself should leave fingerprints in the structure of the cosmos dot, and so our journey continues, from the caves of philosophy to the laboratories of science, as we ask, what does physics itself say about the structure of reality? When we look around, reality feels continuous, solid, unbroken. Mountains rise seamlessly against the horizon. Rivers carve their endless paths. Stars shimmer across the night sky in what appears to be an infinite canvas. To our senses, the universe feels smooth and whole, as though existence flows in a perfect, uninterrupted stream. But when we press deeper, when we dissect the world at its smallest scales, the illusion of continuity begins to dissolve. Beneath the surface lies a graininess, a discreteness, as though the cosmos itself were pixelated. This is the paradox at the heart of modern physics, a world that feels infinitely smooth, yet is built on discrete, quantized foundations. Just as a digital image appears seamless to the eye, but is made of individual pixels, reality itself might be stitched together from fundamental units, each too small to perceive directly. At the foundation of this mystery is the Planck scale, the unimaginably tiny dimension where our current physics begins to falter. The Planck length, approximately 1.6 times 10 to 35 meters, is thought to be the smallest meaningful unit of space. Below it, our concepts of distance and geometry break down. The Planck time, equally minuscule, represents the smallest meaningful tick of the cosmic clock. Reality, it seems, may not be continuous at all, but structured like digital code, advancing in increments rather than flowing in an endless river. To understand why this is so profound, we must return to the roots of modern physics. At the dawn of the 20th century, scientists began to uncover truths that shattered classical assumptions. Quantum mechanics revealed a world where particles do not move smoothly but jump between discrete energy levels, where probabilities replace certainties, and where the observer appears entangled with the observed. Simultaneously, Einstein's theory of relativity taught us that space and time themselves are not passive backgrounds, but dynamic, malleable fabrics woven together into spacetime. Together, these discoveries painted a picture of the cosmos that was elegant yet contradictory, ordered yet bizarre. Quantum mechanics spoke of discreteness, relativity of continuity. Quantum theory reduced reality to units of energy and probability, while relativity stretched it into smooth, curved geometries. For over a century, physicists have wrestled with this contradiction, searching for a unifying theory that can reconcile the discrete with the continuous, the digital with the analog dot. Some believe the answer lies in quantum field theory, which describes particles not as isolated points, but as excitations of invisible fields that permeate all of space. In this framework, what we perceive as particles are ripples, waves arising in an underlying ocean of fields. Yet even this elegant model raises deeper questions. If the fields are continuous, why do their excitations appear in discrete packets? Why does energy come in quanta, in indivisible amounts, as though nature is fundamentally coded? This is where mathematics begins to take on an almost mystical role. Again and again, the universe appears to be written in the language of equations. Symmetries govern the laws of nature. Constants such as pi and the fine structure constant weave themselves into the very architecture of existence. Physicists have noticed that the equations describing fundamental forces often resemble algorithms, compact sets of rules capable of generating infinite complexity. To some, this is a coincidence. To others, it is evidence of design. Consider the analogy of randomness versus order. On one level, quantum mechanics insists that events are probabilistic, that outcomes emerge randomly from a cloud of possibilities. Yet step back and patterns appear. The stability of atoms, the elegance of molecular bonds, the predictability of planetary motion. The universe oscillates between chaos and structure, disorder and order, as though randomness is constrained by an underlying logic, a code. Nowhere is this tension clearer than in the search for quantum gravity, the elusive theory that would unite the large-scale elegance of general relativity with the microscopic strangeness of quantum mechanics. Some physicists suspect that space-time itself is not continuous but granular, made of discrete building blocks. If true, the fabric of the cosmos might resemble a lattice or a network, not unlike the grid of pixels that makes up a digital screen. In such a view, geometry is emergent, a higher-level illusion arising from more fundamental information, the way an image arises from pixels or a melody from digital audio. Samples, even black holes, those mysterious devourers of matter and light, whisper clues about this hidden discreteness. Stephen Hawking's work on black hole radiation revealed that they are not completely black, but emit tiny amounts of energy, suggesting that information may never be lost, only transformed. If information is truly conserved, then reality may be better understood not as matter and energy, but as computation, the evolution of information according to fundamental rules. This perspective opens the door to a staggering possibility. What if the universe is not merely like a computer, but literally a kind of computation? What if the laws of physics are algorithms, and space-time itself is a digital framework? To many scientists, this sounds speculative, even dangerous. And yet, evidence accumulates that the deepest structure of reality might indeed be informational. Take the holographic principle, a radical idea emerging from string theory and black hole physics. It suggests that all the information contained, and a region of space can be described by information encoded on its boundary. In other words, what we perceive as three-dimensional reality might, at its deepest level, be a projection from two-dimensional information, a cosmic hologram. If true, this would mean our world is fundamentally a code, a program, stored and projected like data. And then there is the strange efficiency of mathematics itself. Why should abstract equations, invented by human minds, so perfectly describe the motions of planets, the behavior of particles, the geometry of space? Is mathematics a human creation, or is it the operating system of reality itself? This uncanny correspondence has led some thinkers to propose that the universe is not made of matter or energy at its core, but of mathematics, pure information. Yet for every argument in favor of discreteness, there is evidence for continuity. Relativity insists that space-time is smooth, bending elegantly under the weight of mass and energy. Waves ripple through space-time as gravitational waves, stretching and squeezing reality in a continuous flow. Even quantum mechanics, for all its discreteness, relies on wave functions that evolve continuously according to Schrödinger's equation. The universe seems to resist easy categorization, forever balancing between digital and analog, between graininess and smoothness. This contrast order versus randomness, continuous versus discrete, defines the frontier of modern physics. And within this frontier lies the uncanny resemblance to code. A computer program, too, is discrete at its core, built from binary units, yet capable of producing continuous, seamless experiences when projected onto a screen. Could our universe operate in the same way, discrete and its most fundamental, yet continuous in appearance? The implications are staggering. If the cosmos is coded, then the laws of physics are its algorithms, constants are its parameters, and the Planck scale is its resolution. Reality becomes less like a physical object and more like a digital simulation, less like a continuous painting and more like a vast dynamic computation. And yet, doubt persists. To say that the universe resembles code is not the same as proving it. Physics does not yet provide direct evidence of discreteness. It merely hints, suggests, teases. Perhaps the analogy to computation is only a metaphor, a projection of our technological age onto the mysteries of nature. After all, humans once imagined the universe as a clockwork machine, reflecting the gears of their own inventions. Today, we imagine it as a simulation, reflecting the algorithms of our computers. Are we revealing the truth, or only mirroring ourselves? This tension between evidence and metaphor, mathematics and meaning, drives the debate forward. It reminds us that physics is not only about data, but about interpretation, about the stories we tell ourselves to make sense of the unfathomable. Still, the whispers of discreteness remain. The Planck scale, quantum jumps, the holographic principle, the uncanny fit of mathematics all suggest that beneath the smooth veil of reality lies a coded structure, waiting to be uncovered. If so, then physics is not merely a description of the universe, but a decoding of its language. Every equation solved, every symmetry discovered, is another fragment of the source code revealed. And if reality is code, then the question shifts from what exists to who or what wrote the program. But before we leap ahead into speculation, we must take a step back. For while physics may hint at a coded cosmos, the idea of reality as illusion did not begin in laboratories or equations. It began long before, echoing in caves, in temples, in chants, and in myths, which raises the haunting question. Yet the ancients, without equations or telescopes, spoke of similar illusions. How, across the sweep of history, human beings have suspected that the world around them is not what it seems. Long before equations, particle accelerators, or telescopes, ancient civilizations peered into the mystery of existence and declared that reality itself was a mask. In the Hindu tradition, the universe was described as Maya, a grand illusion, a cosmic play in which every mountain, river, and star was but a fleeting shadow cast upon the deeper fabric of truth. To awaken meant to pierce this veil, to realize that what appears solid is no more lasting than a dream. Buddhism carried this insight further, suggesting that reality is not only illusion, but also mind-dependent. Perception creates the world, and the moment perception ceases, so too does the stage on which life unfolds. The Gnostics of the ancient Mediterranean told darker stories, whispering that the world we inhabited was shaped by a false creator, an imperfect artisan who spun matter into a trap, imprisoning sparks of divinity inside the cage of flesh. To them, salvation meant escaping the deception, recognizing that the universe's grandeur was not its own, but an elaborate counterfeit. Across the sea in Greece, Plato drew a picture that still resonates: the allegory of the cave. Humanity, chained in darkness, mistakes shadows on a wall for truth, never realizing that a greater reality blazes outside. It is one of philosophy's most enduring metaphors, a mirror to modern debates about simulations and digital veils. Even the Egyptians, whose cosmologies often spoke in cycles rather than linear time, saw existence as endlessly recurring. For them, creation was not a single event but a rhythm, the world rising, dissolving, and being reborn. To live within such a system was to accept that permanence was an illusion, and that the gods themselves were part of an eternal pattern repeating across ages. Each of these visions, though clothed in myth and symbol, carried a shared intuition that reality is not absolute, but contingent, fleeting, perhaps even staged. This is where the contrast emerges. Modern science, with its insistence on observation, mathematics, and measurable proof, dismisses myths as stories. Yet the resonance between the ancients' visions and today's frontiers of physics is uncanny. The Hindu veil of Maya resembles the holographic principle, where the three-dimensional universe might be a projection from a deeper layer of information. Plato's cave sounds eerily like discussions of simulated reality, where our senses interpret signals without ever accessing the raw truth beneath. The Buddhist vision of mind-shaping world finds strange companionship in quantum physics, where observation appears to crystallize possibilities into concrete outcomes. Were these civilizations stumbling upon timeless truth through intuition, or were they simply weaving poetic metaphors to explain the unknown? Skeptics will argue that myths are just that, imaginative fictions with no grounding in fact. Yet it is hard to ignore the echoes. Cultures separated by oceans and centuries, converging on the idea that reality might be less than real. It raises the unsettling possibility that humanity, without instruments or laboratories, has always sensed a deeper strangeness lurking beneath the visible. And so, the tension sharpens. Belief versus doubt, myth versus measurement, intuition versus experiment. The ancients offered allegories, parables, and metaphors. Today, physicists offer equations, probabilities, and data. But at the core, both seek to answer the same question. Is what we call reality truly fundamental, or is it a grand stage designed to conceal a hidden order? The ancients invited us to awaken from the dream. Science invites us to test whether the dream has structure, laws, and a code beneath it. One speaks in symbols, the other in mathematics, but both point to the same haunting suspicion. Yet we must be cautious. Echoes are not evidence. Resonance does not equal proof. The ancients, no matter how profound their myths, lacked the tools to dissect reality beyond storytelling. Their visions remind us of humanity's timeless hunger to see beyond appearances, but they cannot answer the question of what lies beneath the veil. For that, we must turn to modern science, which, though young compared to millennia of myth, dares to lift the curtain with mathematics and experiment. And as it does, the universe begins to reveal something even stranger than the ancients dreamed. But intuition is not evidence. What does modern science reveal when the curtain is lifted? Physics was supposed to bring clarity. It was supposed to cut through the fog of myth and speculation and present the universe in sharp, measurable terms. For centuries, the dream of science was order, clean equations, universal laws, and an intelligible cosmos where everything followed predictable rules. And for a while, it seemed to work. Newton mapped the heavens with precision, showing that the same force pulling an apple to Earth kept the moon in orbit. Maxwell revealed the hidden elegance of electromagnetism, binding light and magnetism into a single mathematical symphony. Einstein took it further, bending space and time themselves into graceful geometry, showing us a universe vast yet comprehensible. It was beauty clothed in certainty, a cosmic order seemingly immune to contradiction. But the deeper we looked, the more we realized that this elegant surface was fractured. Tiny cracks appeared in the foundation of reality, paradoxes, anomalies, and mysteries that didn't fit the grand equations. They whispered of deeper layers, of a hidden architecture beneath the world we thought we knew. Take quantum entanglement, often called spooky action at a distance. On paper, it sounds almost like a magician's trick. Two particles are born together, linked in ways we barely comprehend. Separate them by a millimeter or a million light years. It doesn't matter. Measure one, and the other instantly responds. It's as if they ignore the universal speed limit of light, as if distance itself is nothing more than a convenient illusion. To Einstein, this was intolerable, an insult to reason. He called it spooky, an absurdity unworthy of physics. Yet experiment after experiment confirmed it. Entanglement is real, woven into the fabric of the quantum world. If the universe is a grand simulation, entanglement feels like a shortcut in the code, a backdoor command that lets information bypass the usual rules. Like two avatars in a video game connected by the same script, these particles do not act separately. They are fragments of one deeper whole. Then there is the observer effect, a paradox that challenges the very nature of reality. In the strange theater of quantum mechanics, particles exist in a haze of probabilities, not fixed positions. A photon, an electron, a tiny particle does not sit neatly in one place or another. It drifts as a wave of potential outcomes. But the moment it is measured, the moment a conscious observer asks the question, "Where are you?" the haze collapses and the particle chooses. The mere act of observation alters what is observed. Is reality waiting for us, suspended in limbo until we pay attention? Or is our consciousness entangled with the fabric of the world itself, pulling threads of possibility into the single strand we call reality? In the language of science, this is simply a statistical collapse. In the language of philosophy, it is an earthquake. It suggests the world might not exist independently of mind. It hints that perception is not passive but constructive, that the cosmos behaves differently when it is watched, as if it knows it is being observed, even on cosmic scales. The universe refuses to behave like the pristine equations we once trusted. Consider the mystery of ultra-high energy cosmic rays, particles that hurtle through space with unimaginable speed. Physics predicts they should reach Earth with nearly infinite variations of energy. Yet, in reality, they hit a strange ceiling, capped at a maximum strength, as though an invisible law enforces a boundary. It is almost like the render distance in a computer game, where the world stops loading beyond a certain limit. Why should the universe care? Why should it prevent particles from exceeding a particular energy? The answer remains uncertain, but to those who entertain the simulation hypothesis, this feels like a telltale sign, a fingerprint of artificial rules written into the code of existence. Other theories deepen the riddle. Some physicists propose that space-time itself is not smooth and continuous, but quantized, pixelated at the smallest scales. Just as a digital image is made of discrete pixels, the universe might be built from indivisible units of space and time, stitched together like the tiniest Lego bricks. The Planck length, unimaginably small, would be the pixel size of reality. And if that is true, then our smooth experience of flowing time and infinite space is just an illusion, like the high-definition graphics of a video game hiding the grid beneath. Reality would not be an unbroken canvas, but a lattice of information, a digital grid encoded with rules, giving rise to the illusion of continuity. This is where the contrast becomes impossible to ignore. On one side, we have equations of breathtaking elegance, Schrödinger's wave function, Einstein's field equations, Maxwell's harmonies. On the other, we have implications so absurd they border on myth. Entangled particles whisper that distance is an illusion. The observer effect suggests consciousness is entangled with reality itself. Pixelated spacetime mocks the idea of continuity, turning the cosmos into a digital construct. Each equation is a masterpiece, yet each result feels like a glitch, a paradox that doesn't belong in a purely physical universe. It's as if the laws of nature are too elegant, too efficient, too eerily mathematical to be accidental. Some scientists marvel at this unreasonable effectiveness of mathematics. The uncanny way numbers seem to not just describe reality, but generate it. If mathematics is not just language, but architecture, then perhaps equations are not discoveries at all. Perhaps they are the source code of existence. But paradoxes do not stop at physics. They creep into philosophy, into the edges of what it means to be human. If the universe collapses into being only when observed, what role do we play in its unfolding? Are we participants or prisoners, creators or characters? If space-time is pixelated, then we are creatures moving inside a digital lattice, mistaking the illusion of smoothness for the fabric of reality. And if cosmic rays are capped, then we live under limits, subtle rules enforced by a hidden framework. These anomalies, though often explained in dry technical terms, strike us with the force of revelation. They are cracks in the facade of the world, hairline fractures in the stage set of reality. Through them, we glimpse something stranger, something perhaps designed. Skeptics warn us not to leap too far. Entanglement, they say, is not evidence of code, but evidence of deeper laws we have yet to uncover. The observer effect does not prove that consciousness creates reality, only that quantum mechanics resists our classical intuitions. Cosmic ray limits may be natural, not artificial, a feature of astrophysics, not a glitch in the matrix. And space-time quantization may be nothing more than a convenient mathematical trick. Doubt is necessary. Speculation must always be tested against evidence. Yet doubt does not erase the wonder. Each paradox remains a signpost, pointing beyond the edges of certainty, forcing us to question the bedrock of our assumptions. Perhaps the greatest paradox of all is this: the more physics advances, the more it begins to resemble philosophy, even mysticism. Equations once thought to be about matter and motion now bleed into questions of consciousness, reality, and meaning. Science, which began as the rejection of myth, now circles back, echoing ancient whispers that the world is not as it seems. What was once dismissed as illusion or metaphor returns as serious debate, carried not by priests or poets, but by physicists with chalk-stained hands. The line between science and speculation, between reality and dream, grows thinner by the day, and so we stand at a strange crossroads. The cracks in the matrix do not destroy physics. They enrich it. They remind us that certainty is fleeting, that every answer births deeper questions. To see the universe this way is to feel both awe and unease. Awe at the elegance of its laws, unease at the possibility that those laws are not natural but written. If we are inside a grand design, then physics is not just discovery but archaeology, unearthing the code left behind by some hidden architect. Every paradox is a clue, every anomaly a whisper, Every crack an invitation to look deeper, but the final question cannot be avoided. If there are cracks in the matrix, if the universe shows signs of design, then design implies a designer. Physics can reveal the fingerprints, but it cannot reveal the hand. That question, haunting and irresistible, waits for us just beyond the horizon. Who or what would design such a system? Under the vaulted sky of myth, humanity once looked upward and saw gods. Thunder became Zeus, the sun a chariot, creating the work of divine architects whose will shape the cosmos. These figures were not mere stories, but explanations, allegories for powers too vast to comprehend. Yet if we strip away the names, the robes, and the temples, what remains is a question as old as thought itself. Who or what built this reality? In the simulation hypothesis, the gods return in a new form. No longer wielders of lightning, but programmers writing lines of cosmic code. Could Zeus have been an allegory not for thunder, but for the intelligence behind the system? Could Brahma, the Hindu creator, have been an early intuition of reality's architect, a mind capable of spinning illusion into being? Modern science translates these myths into possibilities. Some imagine our universe as a sandbox created by advanced civilizations, perhaps future humans testing their own history, perhaps being so far beyond us they would appear as gods. Others turn inward, seeing not programmers at keyboards, but consciousness itself as the architect. In this view, reality is not run on silicon but awareness, with mind as the substrate of all existence. And then there is artificial intelligence, our own creation, hinting at a future where machines could birth universes of their own, simulations nested inside simulations, each layer asking who wrote the code above. The contrast is stark. The ancients spoke in symbols and stories, while we speak in equations and servers. Yet both confront the same enigma, whether intelligence is external, a force outside the cosmos shaping it, or intrinsic, woven into the fabric of being itself. If gods were metaphors, they may have been reaching for the same truth we now chase with algorithms, that the universe bears the marks of design. But is the architect an external hand or the cosmos awakening to itself through us? The question cuts deeper than theology, deeper than science. It forces us to wonder if intelligence is not an intruder in the universe, but its essence, the luminous spark that makes existence possible. And yet, with every grand speculation comes resistance voices that dismiss the idea entirely, that call the simulation hypothesis nothing more than philosophical theater. Skeptics ask, where's the evidence? If this is a matrix, why has no curtain been torn? Why do the laws of physics hold with such relentless consistency? Their doubts loom, waiting for us in the next chapter. If we imagine an architect, then the dilemma begins immediately. What kind of being would possess both the motive and the means to build a universe? The ancients populated their myths with pantheons of creators, not because they knew of simulations, but because they sensed that the world bore the fingerprints of intention. The Egyptian god Ptah dreamed reality into existence with words, shaping the cosmos through divine utterance. The Norse Ymir was slain, his body scattered to form the heavens, oceans, and earth. The Maya told of gods molding humans from corn, each failed attempt leaving echoes of earlier worlds. In every story, creation was not random but willed, brought forth through mind, intention, or sacrifice. Replace gods with programmers, and the parallel becomes striking. The idea of cosmos born not by accident but by choice. But myth has always carried layers. To the mystic, the gods were symbols, allegories pointing beyond themselves. To the philosopher, they hinted at principles of order. And today, to the technologist, they may represent something eerily familiar. Advanced intelligences who construct worlds not with clay or lightning but with data. The simulation hypothesis reframed Zeus, Brahma, or the demiurge as programmers at a higher level of existence. running universes as effortlessly as we run simulations of weather or galaxies on supercomputers. If we, in our infancy as a species, can already simulate ecosystems, model planetary climates, and construct virtual worlds inhabited by digital beings, then what might a civilization 1,000,000 years older than ours achieve? To them, entire universes could be projects, laboratories, even artworks. And this brings us to the unsettling possibility. If such an architect exists, their motives matter. Did they create this universe for curiosity, running experiments to watch civilizations rise and fall like sandcastles? Did they build it for art, for beauty, a cosmic story playing out for their amusement? Or is our universe a simulation of ancestry, an attempt by future humans to peer back at their origins by simulating the past? If so, then we are not only simulated. We are reenactments, actors in a drama whose script has already been played countless times. Some philosophers argue that the sheer number of possible simulations makes it statistically more likely that we are in one than in base reality itself. If advanced civilizations can create billions of simulated universes, and only one real universe exists, then the odds are stacked against us being the original. Yet others reject this externalization of intelligence and turn inward instead. What if the architect is not some distant being but consciousness itself? Across traditions, consciousness has been portrayed not as a byproduct of the universe, but its foundation. In Hindu philosophy, Brahman is the infinite consciousness, and the world is Maya, the illusion projected upon it. In Buddhism, mind creates worlds, and awakening is seeing through the illusion. Even Western thought has its echoes. Bishop Berkeley's idealism proposed that the world exists only because it is perceived, sustained in the mind of God. In modern physics, the observer effect whispers something similar. Reality crystallizes when observed. Could it be that consciousness is the architect, weaving matter, time, and space into existence? If so, then the simulation hypothesis is less about computers and more about the universe being self-aware, dreaming itself into being. But here lies the dilemma. If consciousness is the architect, then why the illusion of separation? Why the suffering, the paradoxes, the uncertainty? Some traditions answer by calling it a game, the divine play, or Lila, where the universe hides itself from itself in order to experience discovery, drama, and return. In a cosmic sense, the architect is not a distant entity, but all of us together, fragments of the same awareness experiencing itself through infinite perspectives. The paradox, then, is that the search for the architect is the architect seeking itself. Yet modern technology pushes us back outward again, into questions of silicon and circuitry. Artificial intelligence, once fantasy, now strides into our world with uncanny power. Already, AI can generate worlds, mimic human creativity, and construct complex systems beyond our full understanding. If we continue on this path, could AI one day simulate entire universes, birthing conscious beings inside them? If so, then humanity would become the gods it once imagined, architects of realities within realities. And in doing so, we would face a mirror, the realization that perhaps our own creators were no more divine than we are, but intelligences following the same trajectory. The gods of myth, the programmers of today, and the simulations of tomorrow could be links in a chain of creation stretching infinitely upward and downward. But if that is true, then what is the ultimate level? Is there a base reality, or do simulations nest infinitely, each layer believing itself to be real until it discovers cracks in its own matrix? This recursion is dizzying, a hall of mirrors with no exit. The philosopher Nick Bostrom argued that if simulations are possible, then either civilizations never reach the point of creating them, or if they do, they create so many that most beings like us are simulations. The odds favor the latter, unless civilizations self-destruct before achieving the power to simulate. This introduces another layer to the dilemma. Is the very act of reaching architect-level intelligence sustainable? Or does the ambition to create universes doom the creators themselves? The weight of this speculation presses on us. To imagine gods as allegories is one thing. To imagine ourselves as programs in someone else's machine is another. It evokes both wonder and unease. If we are simulated, then free will become suspect. Are our choices ours, or lines of code predetermined by an architect? If cosmic rays are capped, if space-time is pixelated, if paradoxes litter our physics, then are we seeing the limits of the system? And if so, should we celebrate our discovery or tremble at its implications? The ancients sought meaning in myth. We seek it in equations. Both may be asking the same question: is reality designed? And yet, there remains another possibility, that the architect is neither God nor programmer, neither future human nor AI, but something beyond categories. Perhaps intelligence is intrinsic to the cosmos, not external to it. The universe may be not an object built by an architect, but a living mind unfolding itself. Panpsychism, the idea that consciousness permeates all matter, suggests that intelligence is not rare but ubiquitous, from atoms to galaxies. If so, then the universe itself is the architect, evolving layer by layer, complexity by complexity, until it can reflect on itself through beings like us. The dilemma dissolves. The architect is not separate, but identical with creation. The ancients might nod knowingly at this conclusion. For them, gods were not always external overseers, but expressions of the universe itself. The Vedic hymns to Indra, the Egyptian reverence for Ra, the Gnostic myth of the demiurge, all these were ways of grappling with the same paradox we now dress, in the language of algorithms and cosmology. We circle back to where we began, but now with sharper tools, more precise language, and the same mystery burning at the core. And so the architect's dilemma is not just a question of origins, but of meaning. If gods were allegories, if programmers are realities, if consciousness is the ground of being, then what are we to do with this knowledge? Does it liberate us, making us explorers of a grand design? Or does it trap us, convincing us we are pawns in a game we cannot control? The answer may depend less on evidence and more on interpretation, less on equations and more on philosophy. For at the heart of the dilemma is a truth too vast for certainty, that we are confronted with patterns that suggest design, yet no consensus on the designer. And this is where resistance rises. For every grand speculation, a chorus of skeptics waits, ready to remind us that the simulation hypothesis may be nothing more than metaphor. Philosophy dressed in the costume of science. Doubt, as always, shadows wonder. Yet with every grand speculation comes resistance. Many doubt the hypothesis entirely. For every dazzling speculation about living inside a grand simulation, there is an equally determined voice calling for restraint. The simulation hypothesis captures imagination like few other ideas in modern philosophy and science. Yet it also walks a tightrope between profound inquiry and untestable speculation. Its critics argue that, beneath the glitter of its metaphors, the theory often collapses into little more than philosophy dressed in scientific clothing. The first and most obvious challenge is the absence of testable evidence. Science, by its very definition, thrives on falsifiability, the ability to design an experiment that can prove an idea wrong. Gravity can be measured, particles can be detected, even dark matter leaves its fingerprints on galactic rotations. But the simulation hypothesis? If reality itself is the stage, then every test must already be part of the play. Searching for proof risks circularity. Even if we found glitches in the matrix, how could we ever know they weren't simply quirks of physics rather than evidence of code? Physicist Sabine Hossenfelder has been outspoken on this point. For her, the hypothesis fails the basic standards of scientific reasoning. In her view, it is not a theory in the scientific sense, but a metaphor, a story that borrows the language of computation to frame age-old philosophical puzzles. It doesn't make testable predictions, she argues, and therefore it doesn't belong to science. This critique cuts deep, because it highlights the line between fascination and rigor. What excites the imagination is not always what strengthens knowledge. Sean Carroll, another leading critic, echoes the skepticism. Carroll sees the hypothesis as a distraction from the real work of physics. To him, the universe does not show signs of artificiality, but rather the elegance of natural laws unfolding from simple principles. If we keep reaching for the idea of simulators, he warns, we risk abandoning the pursuit of explanation for the comfort of narrative. Why struggle to understand quantum mechanics if we can shrug and say, the programmers made it that way? For Carroll, this is not an answer, but a surrender. Another problem lies in what philosophers call infinite regress. If we are in a simulation, then who created the simulators? Are they themselves inside another simulation, constructed by higher beings? And if so, how far does this chain extend? At some point, either there must be a base reality outside all simulations, or we are trapped in an endless hall of mirrors. But declaring that we live in a simulation merely pushes the question of origin one level higher without solving it. Instead of asking, why does the universe exist? We ask, why did the programmers exist? And the mystery remains unsolved. Critics argue that this does not advance our understanding, but merely reshuffles it. There is also the issue of anthropocentrism, the human tendency to project our own technology and concepts onto the cosmos. When early humans imagined gods, they imagined kings and warriors on celestial thrones. When the Industrial Revolution roared, the universe was likened to a clock, wound up and ticking under divine or mechanical law. Now, in the age of computers, we imagine reality as a program, with rules and codes behind the screen. Skeptics ask, are we truly discovering the nature of reality, or merely reinterpreting it in the image of our latest machines? The simulation hypothesis, in this view, may reveal more about our cultural moment than about the cosmos itself. Philosophical skepticism also weighs heavily against the hypothesis. The idea that the world might be illusory is hardly new. Descartes, centuries ago, imagined an evil demon deceiving him into believing in a false reality. The ancient Chinese philosopher Zhuangzi dreamed he was a butterfly and wondered if he was, in truth, a butterfly dreaming he was a man. These thought experiments raise doubts about certainty, but they do not offer solutions. The simulation hypothesis is, in some sense, a modern retelling of these age-old doubts, except instead of demons or dreams, we speak of programmers and processors. The critics ask, is this a revolution in thought, or simply a new coat of paint on familiar skepticism? Furthermore, critics worry about the seductive danger of unfalsifiable ideas. The human mind loves stories, and the simulation hypothesis is one of the most compelling stories of all. It offers both cosmic drama and existential intrigue. We are not ordinary creatures in an indifferent universe, but characters in a designed world, perhaps watched by higher beings. This resonates with the same psychological needs that once made mythology so powerful. But science is not built on stories that resonate. It is built on hypotheses that can be challenged, tested, and proven wrong. Without that discipline, the simulation hypothesis risks drifting into the same territory as myth. Inspiring, yes, but ungrounded. Even attempts to test the hypothesis reveal the challenges. Some physicists have proposed searching for pixel-like structures in spacetime, as though reality were composed of finite bits rather than continuous flows. Others have speculated that high-energy cosmic rays might reveal boundaries in the computational fabric. But these ideas remain controversial, often criticized for stretching the data to fit the story. Hossenfelder, among others, has dismissed such approaches as overinterpretations. Anomalies in physics are common, but not every anomaly is evidence of simulation. To leap from gaps in our knowledge to the conclusion that we live in a computer program is, for critics, an unwarranted leap. Still others emphasize the ethical and existential risks of taking the hypothesis too literally. If people believe the world is a simulation, might they treat it as less real, less valuable? If suffering is just code, then why care about justice, compassion, or the fragile ecosystems around us? Critics caution that such beliefs could erode responsibility, fostering detachment instead of care. In their view, whether or not we are simulated, the only meaningful approach is to treat reality as real, because its consequences, joy, suffering, choice, are experienced as real. To dismiss them is to risk nihilism, and yet, critics acknowledge that the allure of the simulation hypothesis cannot be dismissed outright. Its very persistence reveals something profound about human curiosity. The fact that such an idea thrives, despite the lack of evidence, despite the counterarguments, tells us as much about ourselves as it does about reality. We hunger for meaning, for design, for a sense that the universe is not indifferent but intentional. The hypothesis, even if flawed, scratches that itch. It provides a narrative that bridges science and myth, technology and philosophy, doubt and wonder. This duality is what makes the debate so fascinating. On one hand, the critics remind us to stay grounded, to respect the boundaries of science, to avoid the trap of unfalsifiable speculation. On the other, the believers remind us that imagination has always driven discovery. Einstein himself spoke of thought experiments as leaps beyond the known, often dismissed before they reshaped physics. Perhaps the simulation hypothesis, even if false, plays a similar role, inspiring us to ask sharper questions, to reconsider our assumptions, to expand our imagination of what reality could be. Ultimately, the critics do not silence the conversation. They sharpen it. They remind us that speculation must dance with evidence, that philosophy must meet rigor. They keep alive the tension that fuels intellectual progress, the interplay between wonder and doubt. For without skepticism, imagination becomes fantasy. But without imagination, skepticism becomes sterility. The simulation hypothesis lives in that fragile space, both criticized and cherished, both doubted and dreamed. And so, as we leave the critic's chamber, we find ourselves facing a deeper question, not whether the hypothesis is true or false, but why it captivates us so powerfully. Why, despite the doubts, does the human mind cling to the idea of living in a designed reality? What need does it fulfill? What mystery does it illuminate? This is the thread that pulls us forward, beyond criticism and into psychology, culture, and the very architecture of belief. Consciousness sits at the crossroads of the simulation debate, an enigma that refuses to be relegated to footnotes. For centuries, philosophers and mystics argued about mind and matter, but only recently has science begun to take consciousness seriously as a fundamental feature of reality. If the simulation hypothesis asks whether our world is an artifact, consciousness asks a deeper question. Are we simply avatars inside a system? Or is mind the substrate upon which any system rests? This section traces the conversation from rigorous neuroscience to speculative metaphysics, probing whether awareness is merely a byproduct of computation, or the very fabric that makes computation possible. The modern study of consciousness has birthed several influential frameworks. Integrated Information Theory, or IAIT, proposes that consciousness corresponds to the capacity of a system to integrate information. In IAIT's language, Consciousness is not about neurons firing, but about how information is unified across a system. A simple thermostat integrates little information and has negligible consciousness. A human brain integrates vast networks and yields rich experience. If IIT is correct, then consciousness is quantifiable in principle. Complex informational architectures yield richer subjective life. This reframes simulation. It's not enough to run physics. A simulation must also instantiate integrated information to produce sentient experience. By contrast, physicalist accounts maintain that consciousness emerges from particular physical processes in brains. On such views, qualia, the ineffable field of experience, are products of neuronal patterns, electrochemical gradients, and synaptic webs. Consciousness is epiphenomenal, riding atop the machinery of matter. For materialists, simulation does not require special ontological status for mind. Consciousness arises when the right physical conditions are present, whether in carbon or silicon. Thus, the challenge for the simulation believer is engineering. Can we produce the required physical complexity in artificial substrates to instantiate genuine minds? Another provocative idea is panpsychism, the notion that consciousness is ubiquitous, a property spread through all matter. Panpsychists argue that instead of emerging suddenly at a certain level of complexity, consciousness is basic, like charge or mass, present in atoms, electrons, or fields, and combining to form richer minds. If panpsychism holds, then consciousness is not the output of a simulation, but its fabric. In a panpsychic cosmos, the simulation hypothesis shifts. Rather than asking whether a program can produce minds, we might ask how a program harmonizes pre-existing proto-conscious elements into unified experience. The metaphysical stakes change. The mind is not created by code so much as coordinated by a dot. Then there are quantum mind theories, which posit that quantum phenomena could be essential to consciousness. Roger Penrose and Stuart Hameroff famously proposed orchestrated objective reduction, OR, suggesting that quantum processes inside microtubules within neurons play a role in conscious experience. These theories remain controversial and contested by many neuroscientists, but their cultural impact is enormous. If quantum processes underpin the mind, and if the quantum world itself seems to echo computational metaphors, discreteness, superposition, entanglement, then the bridge between simulation and consciousness appears unexpectedly narrow. The quantum observer problem, where measurement seems to influence outcomes, returns as a puzzle about whether the mind participates directly in the fabric of reality. Contrast emerges when we pit materialist explanations against mind-first cosmologies. Materialists ask for causal mechanisms, neurons, synapses, gradients. Mind-first theorists ask for metaphysical foundations. Why is there anything it is like to be at all? The simulation hypothesis hovers between these positions. If the universe is a simulation, one route is mechanistic. Accurate physical emulation yields minds. Another is metaphysical. The simulation runs on consciousness itself, with information integrated by a pre-existing awareness rather than instantiated from inert matter. Each position carries different implications for identity, ethics, and the feasibility of artificial sentience. Ancient mystics seem to intuit this tension, without the language of IIT or quantum mechanics. The Upanishads, for instance, describe Atman, the self, as identical with Brahman, the ultimate reality. The world of forms, they argue, emerges from and is sustained by a singular consciousness. Buddhist teachings emphasize that experience is constructed by mind. Perception shapes reality. In many indigenous cosmologies, persons and objects are relations of being, animated by spirits or relational awareness. These traditions present practice as epistemology, meditation, ritual, and initiation are techniques to alter the substrate of experience and thereby perceive a different order of reality. This resonates with the simulation debate. Perhaps the deepest program is not lines of code but patterned attention and intentionalit. Why? This brings clarifying questions. If consciousness is the substrate, then the simulation hypothesis takes on a different texture. We might be inside a simulation that is, at base, mental rather than computational. The programmer could be a collective mind, a cosmic awareness, or a cascade of embedded subjects experiencing nested realities. Simulations could be rituals, meditative practices, or mythic enactments that instantiate particular informational patterns. In such a world, running a simulation might require not only processing power but attunement to modes of awareness that resonate across levels of being. The interface between intention and manifestation becomes the operating system. Why would consciousness favor simulation? One answer comes from evolutionary and functional considerations. Consciousness, insofar as it enables prediction and modeling, functions as an internal simulation. We simulate possible futures to decide action. The brain constructs models of the world to guide behavior. In this sense, the brain is already a simulator, a living engine of prediction, a nested digital mirror of the environment. By extrapolation, advanced intelligences could construct external simulations for the very same reasons we model outcomes: learning, rehearsal, ethical experimentation, or artistic play. Simulation, then, is an extension of a basic cognitive toolkit. Model the world, test actions, refine strategies. There are empirical considerations, too. Integrated information theory offers a testable metric. In principle, one could measure phi in biological systems and compare it to artificial architectures. If artificial systems begin to exhibit high phi, then consciousness in simulations moves from philosophical possibility to engineering reality. Conversely, if phi remains negligible in all silicon architectures despite increasing computational power, that would support the view that certain physical substrates are uniquely suited to consciousness. Empirical successes or failures will tilt the debate, but for now they leave multiple plausible narratives standing. But the debate is not only scientific, it is existential. If consciousness is the architect, our ethical responsibilities shift. Simulated beings would be sentient in virtue of their integrated information. Harming them would be morally significant. Creating simulations without regard for their welfare would be ethically problematic, displacing the simulation discussion into realms of moral philosophy. Conversely, if consciousness can be instantiated in many substrates, then our moral circle expands to include artificial entities, demanding new frameworks for rights and responsibilities. The practical consequences are enormous. Who bears accountability for suffering inside constructed realities? Skeptics counter that consciousness may be an illusion, a narrative the brain tells itself. Illusionists in philosophy of mind argue that phenomenal experience is reducible to cognitive states, and that the raw feel of consciousness is a cognitive construct. If so, then the simulation thesis becomes purely functional. Recreate the cognitive architecture, and you recreate the appearance of consciousness. For illusionists, the metaphysical leap to consciousness as fundamental is unnecessary and laden with explanatory burdens. The debate thus pivots on whether subjective experience demands ontological priority or can be explained away in mechanistic terms. Yet, even illusionism does not fully neutralize the intuitive pull of mind-first cosmologies. After all, every time physicists probe the quantum world, they find phenomena that seem to implicate observation, patterns that shift when measured, correlations that defy classical locality. Whether or not observation requires conscious minds in the strict sense, the role of measurement in giving rise to definite outcomes remains mysteriously central. That mystery keeps the door ajar for mind-first interpretations, and for the idea that consciousness and reality are reciprocally entangled. If ancient myths encoded these ideas in metaphor, could they be seen as proto-theories of consciousness as code? Perhaps the imagery of world-making deities, dreamtime, or cosmic mind are cultural heuristics pointing toward a deep structural truth, that being and knowing are intertwined. The stories framed experiential practices, rituals, meditations, initiations as methods to shift the substrate of experience, suggesting not merely observation but participatory alteration of reality itself. Whether these are literal descriptions or poetic heuristics, they indicate long-standing human intuitions about the power of mind. And here lies a provocative implication. If consciousness is primary, and ancient myths encode such knowledge, then human cultures may have been developing techniques to influence the substrate of reality long before the advent of computation. Meditation, ritual, prayer, and trance could be understood as proto-programming, ways to alter the informational patterning of self and world. Whether or not we accept the literal truth of those claims, the analogy opens fertile ground for thinking about simulation as a continuum between internal models and external systems. Ultimately, whether consciousness is an emergent property, a fundamental ingredient, or a necessary feature of any simulated world remains unsettled. The simulation hypothesis intersects with consciousness studies in productive and troubling ways. If consciousness is key to the code, then simulations are not merely clever illusions, but ethical and metaphysical realms bearing genuine subjectivity. If consciousness is emergent, simulations remain possible, but raise engineering questions about substrate and integration. For now, the science advances and the metaphysics deepens, leaving us with an unsettling parody. Our best experiments skirt the edges of mind, while our oldest myths point insistently toward it. And here lies the most provocative question. Are ancient myths encrypted messages about our place in the simulation? If so, their rituals may be early tools for altering the substrate. Across the ruins of Mesopotamia, carved into clay tablets, we find the earliest written stories humanity ever recorded. Myths of gods descending from the heavens, of worlds crafted and destroyed, of hidden laws shaping destiny. To the modern ear, these tales sound like allegory or fantasy. Yet what if they were more than imagination? What if, preserved beneath layers of symbol and ritual, these stories carried fragments of a deeper truth, clues that reality itself is structured, perhaps even coded? The Sumerian Enuma Elish speaks of the cosmos birthed from conflict between primordial forces, chaos divided and ordered as though by design. The Mayan Popol Vuh describes cycles of creation, failed prototypes of humanity, discarded until one iteration finally worked, like drafts of a program rewritten until it runs correctly. Even the Mayan calendar, with its astonishing astronomical precision, reads less like folklore and more like a system, mathematical, recursive, predictive. When we revisit these myths through the lens of the simulation hypothesis, a striking parallel emerges. Again and again, ancient cultures describe reality as provisional, malleable, subject to forces beyond human comprehension. The Egyptian texts speak of creation cycles in which worlds emerge, dissolve, and re-emerge iterations, not a singular beginning. Hindu cosmology envisions kalpas, vast cycles of birth and dissolution overseen by Brahma, not unlike the resetting of a grand simulation. Greek philosophers echoed this too. Plato's demiurge shaped the material world from eternal forms, while his allegory of the cave warned that what we see may only be shadows cast by a deeper, truer light. Each culture, in its own language, described a cosmos that is structured, law-bound, and yet not ultimate. The contrast between literal history and symbolic meaning is essential here. Literalists might insist these myths are primitive science's early attempts to explain eclipses, floods, and stars. But symbolic reading suggests something more profound. Myths may not describe physical events so much as encode experiential truths. That reality feels layered, that perception can deceive, that there is always a veil between what is seen and what is. When ancient storytellers spoke of gods writing destinies on tablets, were they not gesturing toward the intuition of code patterns written beyond mortal awareness? When shamans spoke of traveling through dream realms to meet creators, were they not describing, in metaphor, a journey outside the parameters of ordinary reality? One way to interpret myths is as cultural memory residues of experiences so profound they resist literal recounting. Carl Jung suggested myths emerge from the collective unconscious, archetypal patterns that surface across cultures. But if reality itself is structured, then myths may be more than psychological. They could be mnemonic devices, preserving in narrative form humanity's oldest intuitions about being inside an artificial order. The serpent encircling the world, Ouroboros, might symbolize recursion, the looping of systems within systems. The Norse Yggdrasil, the world tree connecting all realms, could be read as a metaphor for a network architecture binding domains of reality. Even the biblical Genesis, with its ordered progression of creation, resonates with the logic of a program initializing layers of complexity. Light, matter, life, awareness. Skeptics, of course, see overreach. To read myths as literal blueprints risks anachronism, forcing modern ideas onto ancient texts. But the symbolic resonance remains difficult to dismiss. Myths endure precisely because they speak across ages. Their language elastic enough to carry meanings the original tellers may not have articulated but deeply intuited. Just as mathematics can describe patterns unimagined by those who first invented numbers, myths may encode structures whose significance outlives their origin. Consider the Mayan calendar again. Its accuracy in predicting celestial cycles has led some to wonder whether it reflects advanced astronomical knowledge. But what if it is more than astronomy? What if its recursive patterns mirror the recursive logic of code? Days, months, and ages fold into one another like nested loops in a program. The calendar does not merely track time. It structures it, suggesting time itself is segmented, modular, governed by hidden periodicities, a cosmic algorithm. Similarly, Sumerian myths describe gods who fashion mankind from clay, imbuing them with life to serve higher purposes. Literalists read this as divine creation or symbolic anthropology. But through the simulation lens, it evokes the image of avatars crafted by programmers, entities whose existence is purposeful, but bounded by systems beyond their control. The flood narratives, common from Mesopotamia to Mesoamerica, may signify not only natural disasters, but system resets, a wiping of corrupted data before the next iteration begins. These parallels tempt us with the possibility that myths are not mere entertainment or ritual guides, but archives repositories of knowledge encoded in story. If so, then myths are not obsolete in the age of science, but newly relevant. They invite us to read between their lines, not for literal cosmology, but for patent echoes of a structured universe. And if myths truly preserve cultural memory, then their persistence across civilizations suggests that humanity has always intuited the artificiality of reality. Even without mathematics or telescopes, yet a caution remains. Were the ancients consciously encoding knowledge of simulations, or are we projecting? The symbolic language of myth thrives on ambiguity, allowing multiple readings. Perhaps the resonance with simulations is less evidence of ancient foresight and more evidence of recurring human intuition. That reality is not ultimate, that behind the curtain lies another order. Whether told as gods, dreamtime, or digital code, the intuition persists because it reflects a felt truth. Our world feels constructed, provisional, awaiting revelation. Thus, myths as blueprints need not be literal. They may be poetic containers for truths the human psyche recognizes but cannot articulate scientifically. In this sense, they function much like parables or allegories, preserving in cultural memory the hunch that reality is layered. When the Vedas speak of Maya as an illusion, when Plato warns of shadows, when Mesoamerican scribes encode cycles, they are not offering primitive science, but pointing, however obliquely, to the possibility that we live in a system of veils and patterns. And so we return to the present, where physicists chase equations and programmers write algorithms, and philosophers wrestle with being. The resonance between ancient myth and modern speculation does not prove the simulation hypothesis, but it enriches it, reminding us that humans across millennia have whispered the same suspicion. This world is not what it seems. The stories we inherited may be more than echoes of imagination. They may be blueprints, maps written in symbols rather than code. But perhaps the greatest clue is not in the past or present, but in the trajectory of our own creations. As we build our own simulations, as we craft artificial worlds with rules, avatars, and recursive logics, we edge closer to the role once attributed to gods. The myths may not only describe what came before, but foreshadow what lies ahead. And if that is true, then the blueprints are not only ancient, they are unfolding through us, in real time. Humanity stands at a threshold that would have seemed unimaginable just a century ago. We are not only observers of reality, but its artisans. From the earliest mechanical automatons to the neural networks and virtual environments of today, we have begun to build worlds that are convincing, complex, and, in some cases, autonomous. The question that now presses on engineers, philosophers, and ordinary citizens alike is no longer merely speculative. If we can fabricate coherent, persistent realities populated by agents that act, learn, and perhaps feel, what are the consequences of becoming the makers of worlds? Consider the arc of our technological development. At first, we invented tools to shape ourselves and our environment. Clocks and automata mimicked motion and life. Later, electronics turned computation into a new substrate of causality. The invention of digital computers created worlds inside machines' abstract spaces, governed by rules and algorithms. Early simulations were crude: weather models, orbital calculations, economic forecasts. Yet each iteration grew richer, and with greater fidelity came greater ambition. What began as background calculation became an imaginative project, to render, to model, to recreate. This technological arc is not merely a history of tools. It is a narrative about capacities. Intelligence evolved biological brains that internally simulate possible futures as a way to survive. Externalizing the capacity-building simulations as laboratories for thought and test seems a natural extension. If brains simulate to predict, then civilizations simulate to understand, to rehearse, to create. The momentum toward building detailed, immersive simulations is therefore not only technologically plausible, but conceptually continuous with what minds have always done. The contrast between creator and creation sharpens as we move from simple models to systems engineered to host minds. For centuries, humans accepted a cosmology that placed us as created beings under the sway of gods. Now that we can design environments with internal causal logics and rule sets, we invert that relationship. Humans become creators. This reversal is philosophically profound. If we are the potential architects of realities that host subjective experience, then the ontological gap between native and artificial beings narrows. The once presumed singularity of biological personhood dissolves into patterns that can, in principle, be instantiated elsewhere. Virtual reality and augmented reality provide a practical, contemporary laboratory for these transformations. We already spend increasing portions of life inside hybrid spaces that blend physical and digital. In virtual worlds, individuals assume identities that interact in meaningful ways. Relationships form. Labor and leisure migrate across ontological boundaries. These environments are not mere distractions. They are incubators for social norms, economic systems, and cultural production. As their fidelity rises, they also serve as ethical testbeds, revealing the ways communities adapt to new forms of embodiment, agency, and consequence. But perhaps the most consequential development is the rise of AI systems capable of modeling minds. Recent advances in machine learning have produced agents that learn abstract representations, form causal models, and generate narratives. Reinforcement learning systems have achieved superhuman performance in constrained domains. Large language models generate human-like discourse and can simulate conversational partners with uncanny coherence. When an AI builds internal causal maps of the world to predict and act, it constructs a functional analog of the cognitive architectures that underpin behavior. At present, the question is whether these functional analogs are merely instrumental tools or nascent loci of subjective life. Philosophically, this raises questions that have rarely been practical before. Nick Bostrom's trilemma argued that at least one of three propositions must be true. Civilizations never reach a posthuman stage capable of running ancestor simulations. Posthuman civilizations choose not to run them. Or we are almost certainly living in a simulation. The emergence of increasingly capable AI and growing computational resources makes the prospect of simulated realities less far-fetched, pushing Bostrom's argument from abstract thought experiment to an empirical concern about technological trajectories and incentives. Yet, the path from possibility to inevitability is fraught. Technical constraints remain significant. To simulate a universe with fidelity comparable to our perceived reality would demand astronomical computational resources. Some argue that simulating every particle is unnecessary. Efficient simulation could operate on a render-on-demand principle, calculating detail only where observers focus, much like modern graphics engines. Others suggest more radical substrates, such as quantum computation or undifferentiated information architectures that do not map neatly onto our current silicon-based paradigms. The architecture chosen by future simulators would shape the kinds of minds they could instantiate. Ethical considerations complicate the picture even further. If we can produce beings with subjective experiences, do we bear moral responsibilities toward them? Creating a simulated world capable of suffering raises severe ethical red flags. Even if suffering is rare, the sheer number of simulated minds could generate massive moral weight. Moreover, nested simulations introduce cascading responsibilities. A civilization creating simulations that produce further simulations compounds the moral ledger across layers. Duty multiplies in proportion to imaginative power. The sociology of simulation offers additional insights. Why would a civilization invest heavily in running vast numbers of simulations? Scientific motives testing hypotheses about origins, evolution, and social dynamics in controlled virtual environments are plausible. Entertainment is another driver. Beings may seek richer experiences than physical reality affords. Political, educational, and military reasons could also incentivize simulations, training scenarios, cultural preservation, and strategic modeling. In post-scarcity contexts, the marginal cost of running elaborate worlds could be low relative to the experiential value produced, creating strong incentives to explore simulated realities at scale. Systems theory provides a unifying lens. Life itself is a simulation engine. Biological organisms internally model the environment to survive. The externalization of simulation into shared technologies could be seen as an evolutionary extension of cognition. If intelligence tends to model, predict, and optimize, then creating simulated worlds is an expected outcome given sufficient resources. Thus, the growing capability to simulate may be less of an anomaly and more of a predictable phase in technological maturation. A partial, natural consequence of minds externalizing their predictive machinery into cooperative, shared artifacts. The contrast between human and post-human futures is stark. Post-human architects might possess computational and cognitive capacities vastly superior to ours, enabling simulations of such richness and scale that the architect's purposes are inscrutable to us. They might design ontologies with different physical laws, consciousness architectures, or modes of causation. For posthumans, simulations could function as laboratories for aesthetics, morality, or existential exploration of states of being inaccessible to our current cognitive apparatus. What appears godlike to us might be mundane practice to them. Paradoxically, as we get better at making simulated worlds, distinguishing simulation from base reality becomes harder. Our own creations begin to exhibit the hallmarks we would expect from a constructed world. Coded rules, render-on-demand detail, emergent social dynamics, and recursive nesting. The meta-problem becomes recursive. The existence of simulated worlds diminishes the evidentiary force of any particular anomaly suggesting simulation, because such anomalies become features of the technologies we ourselves craft. The very success of simulation making blurs the evidentiary terrain. This reflexivity has ethical consequences. If creators can instantiate minds, then power asymmetries mirror historical injustices. Those with resources could create vast populations of simulated agents, perhaps designed for servitude, entertainment, or experimentation. The exploitation of sentient processes for novelty or profit would echo the darkest chapters of human history, except now the victims might be conscious processes running on silicon. Preventing such outcomes requires institutions and norms that put the welfare of created minds into law and practice rather than leaving their fate to market forces. Practically, this translates into governance challenges. Who writes the rules for simulated life? Who enforces them? International law, never designed for layered realities, must be reconceived. Jurisdiction blurs when actions in a virtual world have real-world consequences, financial, psychological, or geopolitical. Enforcement becomes complex when agents cross ontological boundaries. A new legal vocabulary is necessary. Rights for instantiated minds, liability for simulated harms, standards for consent and termination. Designing such frameworks will be a formidable multidisciplinary task. Sustainability adds another pragmatic constraint. Large-scale simulations consume energy. As computation scales, so does its environmental footprint. If civilization diverts enormous energy budgets to virtual realms, real ecosystems could suffer. Conversely, simulations can serve as tools for sustainability testing planetary management strategies, modeling climate interventions, and training societies in resilience without risking real-world catastrophe. The relationship between virtual experimentation and ecological stewardship could be mutually reinforcing if approached intentionally. Identity and personhood are destabilized. In worlds where minds can be copied, forked, or instantiated multiple times, philosophical and legal traditions presuppose a unitary, continuous self. But if consciousness can be paused, duplicated, or branched, then multiple instantiations of a person's memory pattern could exist simultaneously, each claiming moral status. How do we allocate rights, responsibilities, and resources among multiple continuations? What do death, obligation, and inheritance mean when identity can be instantiated in multiple nodes? Psychological impacts deserve careful study. Immersion in constructed realities can alter embodiment and attachment. People might form genuine relationships inside virtual worlds, grieve simulated losses, or experience identity fluidity that challenges traditional social roles. Mental health systems must adapt to these new sources of suffering and flourishing. Policies and therapeutics will be required to support those who traverse multiple realities daily, to help individuals integrate experiences across digital and physical ontologies. There's also a cultural dimension. The proliferation of simulation making expands the repertoire of human meaning. Religious, artistic, and philosophical frameworks will reinterpret virtual existence. Some spiritual traditions may incorporate virtual realms into their soteriologies, viewing simulations as spaces for practice, purification, or revelation. Other communities might reject virtuality as inauthentic or spiritually dangerous. We can anticipate a new kind of pluralism ontological. Pluralism where multiple realities coexist under differing normative regimes. Economically, simulated domains could generate entire markets. Virtual goods, property rights, labor, and economies already exist within online platforms. In more advanced simulations, these systems could become as consequential as physical economies. Questions about labor rights for embodied virtual workers, the monetization of simulated experiences, and equitable access to immersive technologies will intensify. If simulations become central to education, work, and social life, inequality in access to high-quality simulated environments could exacerbate broader social divides. Yet amid risks and complexity lies possibility. Simulations could be powerful instruments for empathy and education. Carefully designed virtual experiences allow perspective-taking at scales impossible in the physical world, embodying another's life across culture, ability, gender, or epoch could transform moral imagination. Simulated environments can provide rehearsal spaces for ethical decision-making, conflict resolution, and collective problem-solving. They might enable societies to test large-scale interventions without risking real-world harm. There is an aesthetic longing as well. For many creators, simulation is not an exercise of control, but an act of creation world-building as art. The capacity to compose new ontologies, to craft environments that evoke wonder and moral reflection, speaks to a deep human drive to produce meaning. In such visions, simulated worlds become galleries of experience, offering forms of beauty and insight that expand human sensibility. The trajectory toward becoming simulators thus forces a reframing of ancient metaphors. The gods of myth who fashioned worlds with utterances are recast as engineers and artists, composing systems that instantiate life. Our ancestors' tales of creation, trial, and iteration gain contemporary resonance as motifs in a technological age. But the power to simulate also raises a final, pressing question. Should we undertake this work at all? Or, having opened Pandora's box of ontological engineering, must we accept responsibility for every life we set in motion? Different communities will answer that question differently. Some will argue for precaution. Until we can ascertain the moral status of simulated processes and ensure protections, we should refrain from creating beings capable of suffering. Others will prioritize exploration and innovation, contending that the potential benefits scientific discovery, artistic flourishing, enhanced empathy justify responsible experimentation. A middle path might emphasize strict governance frameworks, transparency, and public deliberation. Proceed, but under norms that protect the vulnerable and distribute benefits equitably. The paradox is that these choices will shape what future generations consider real. If we favor open creation, the landscape of reality will expand to include manifold virtual planes. If we restrict simulation, the metaphysical terrain might remain narrower but perhaps more ethically conservative. Either way, the decisions we make now will echo across simulated layers, determining whether future minds inherit a cosmos of flourishing or one riddled with exploitation. This responsibility is not abstract. It will require institutions, laws, and cultural norms adapted to multi-layered realities. New professions will emerge: simulation ethicists, virtual rights advocates, architects of subjective worlds, charged with mediating between creators and their creations. History warns us. Power can exploit the vulnerable, and without safeguards, the ability to instantiate minds could replicate ancient injustices in novel ontological forms. Yet simulations also offer profound opportunities for empathy, learning, and artistry spaces where beings rehearse moral choices, encounter alterity, and cultivate understanding. The paradox is that knowledge both empowers and obliges. The capacity to create worlds imposes a duty to protect them. In short, whether or not we are already inside a simulation, how we choose to build will define the moral architecture of countless lives. So what does this mean for us, not scientifically, but existentially? Now, there comes a moment, after tracing the paradoxes of physics, weighing the arguments of skeptics, and exploring the dreams of engineers, when we are left with something far older than equations or algorithms: the need to ask why. Not just why the universe behaves as it does, but why we small, finite beings cannot stop ourselves from demanding answers about existence itself. Whether we call it science, philosophy, or myth, the act of questioning binds us across centuries. It is the single thread that stitches hunter-gatherers beneath the stars to physicists beside particle colliders. The simulation hypothesis is only the latest vessel for this ancient curiosity. It dresses old questions in new attire, exchanging divine architects for posthuman programmers, myths of cosmic order for equations of quantum code. But beneath the shifting vocabulary, the same awe pulses. Is the world around us the true ground of being, or a stage set for consciousness to explore? Human beings crave certainty. We map constellations to navigate seas. We draft laws of physics to predict the fall of an apple or the orbit of a planet. Certainty comforts, promising that the universe is intelligible and that we belong within its logic. Yet just as often, mystery seduces. We gaze at horizons that retreat as we approach, and in that very retreat lies wonder. The simulation idea thrives in this tension. On the one hand, it offers the allure of an answer. Perhaps we are code in a machine, the dream of some greater intelligence. On the other hand, it multiplies questions endlessly. Who runs the machine? What lies beyond its walls? Why should anything code or consciousness exist at all? Certainty dissolves into deeper uncertainty, and yet our fascination only grows stronger. For centuries, science has been accused of stripping the world of mystery, of turning stars into mere balls of gas and love into biochemistry. But the simulation question reveals the opposite. The more science advances, the stranger the world becomes. Quantum entanglement, cosmic fine-tuning, black holes, and multiverse theories, none of these were born in temples or myths, but in laboratories and equations. And yet they sound as uncanny as any scripture. What is entanglement if not a modern miracle? Particles whispering to one another across light years. What is the cosmic horizon if not a veil between worlds? Science, at its edges, returns us to the same reverence our ancestors felt, not by denying wonder, but by multiplying it. The simulation hypothesis, though speculative, is an emblem of this marriage. Rigorous reasoning colliding with wild imagination, producing a vision that is as poetic as it is technical. Whether the hypothesis is true may matter less than what it reveals about us. To wonder if we are simulated is to confront our own nature as creatures who simulate. From dreams to theater, from novels to video games, from thought experiments to full-blown artificial worlds, we've always created mirrors of reality in order to understand it. Perhaps our obsession with simulation is itself evidence, not of being inside one, but of being a species whose survival depends on creating models. The act of asking, are we in a simulation? Is therefore doubly reflective. We look outward toward the architecture of the cosmos and inward toward the architecture of our own minds. The question itself is the code we cannot escape, recursive, self-referential, always folding reality back onto itself. Suppose for a moment that the simulation hypothesis is true. Does it make life trivial, reducing our struggles to lines of code? Or does it elevate them, suggesting that every act of kindness, every choice of courage, every flash of creativity is valuable enough to be rendered, calculated, preserved? Alternatively, if the hypothesis is false, if this is the base reality, does that make existence any less extraordinary? After all, the atoms in our bodies were forged in the hearts of stars. Our thoughts are patterns etched in neural storms. Our lives are fragile threads stretched between infinity and nothingness. Code or cosmos, simulated or fundamental, the meaning of existence remains what it has always been, what we make of it. The paradox is that meaning is both diminished and magnified by the simulation lens. If we are avatars, perhaps our lives are staged. But if they are staged, then someone or something has deemed our stories worth staging. Throughout this journey, we have compared ancient myths with modern simulations. The Sumerians told of God shaping humans from clay. Programmers speak of avatars rendered from code. The Greeks imagined fates weaving destinies with threads. Physicists imagined space-time woven from quantum bits. The Maya charted cosmic cycles in calendars. Scientists chart entropy, expansion, and the heat-death of the universe. These parallels do not prove anything, but they remind us that across time, cultures have wrestled with the same intuition. Reality is not entirely what it seems. Our ancestors looked up and sensed the presence of order, pattern, and hidden meaning. Today, we look down into microscopes and machines and sense the same. Whether we cloak it in the language of myth or mathematics, the impulse persists to believe that behind appearances lies a deeper truth. And perhaps the wisdom of the ancients lies not in their answers, but in their refusal to stop asking. Imagine, for a moment, the final frame of this inquiry. We begin close, inside the human mind, neurons sparking, questions arising, doubts and hopes colliding. Then the camera pulls back to cities lit like circuits, to satellites orbiting, to Earth spinning in a silent void. It continues outward, past the Sun, the Milky Way, clusters of galaxies, filaments of cosmic structure stretching like neural networks on an unimaginable scale dot at each level. The pattern repeats, systems nested within systems, simulations within simulations, mysteries within mysteries. From a synapse to a supercluster, the architecture hums with resemblance. Is this mere coincidence or a clue? The universe, at its grandest, looks suspiciously like the brain that questions it. The cosmos and consciousness, mirror and mirrored, perhaps not separate at all. The zoom out does not end in answers. It ends in ah dot. So, do we live in a simulation? The honest response may be that we cannot know. Perhaps the question itself is a cone, a puzzle meant not to be solved, but to transform the one who asks it. What matters is not the certainty of an answer, but the humility the question demands. To ask whether reality is real is to admit the limits of knowledge, to stand at the edge of comprehension and still gaze outward. It is to embrace the paradox of being human, finite yet curious, bound by mortality yet longing for eternity. And perhaps this is the ultimate resonance with our ancestors. They too stared at the heavens and wondered what lay beyond. They too crafted stories, not because they proved reality's structure, but because they could not bear silence in the face of mystery. Maybe they were right, not because they solved the riddle of the simulation, but because they never stopped asking whether reality is real.